Hello friends, today's topic of discussion is trigonometrical leveling. Trigonometrical leveling, as the name indicates, in this we are using simple formulas of trigonometry for calculating the levels. First, we'll see what is trigonometrical leveling, its basic definition. So, trigonometric leveling is the process of determining the difference of elevation of station from observed vertical angles and known distance. So we are using angle and distance to calculate the height from a single point. For example, if you can see over here, you have set up instrument at a given point. Now, after knowing the vertical angle of this point and the horizontal distance, we'll find out the vertical height of that particular point. So in trigonometry, we have to find out the elevation by using angle and distance. The vertical angle are measured by means of theodolite. That's why we are using theodolite here. The horizontal distance by instrument. Any instrument you can use like chain or tape. Then the relative heights are calculated using trigonometrical functions. Some trigonometric formulas we have to use over here. Note, if the distance between instrument station and the object is small, correction for earth curvature and refraction is not required. But if we are using the distance is very large between your instrument station and object, then we have to use correction for earth curvature as well as for refraction. Now, the method of determining the elevation of the point by theodolite, there are two cases. First, the base of object is accessible. The base of object is accessible, so we can calculate the vertical and horizontal distance. Second, the base of object is inaccessible. Here, the base of object is inaccessible. So, we can't directly calculate the distance between the base of the object. So, instrument station in the vertical plane as the elevated object. Now, we'll see how to calculate the elevation of such objects. So, case 1, as we have discussed, base of the object is accessible. So, base of the object is accessible over here. Now, for this particular, we'll draw a figure first. Base of the object is accessible. Base of the object is accessible means what? It is on comparatively plain ground, where we can calculate the horizontal distance between 2 points easily. So over here is your line of sight. First reading is always taken on what? Benchmark. So it is our benchmark. Now we'll give the naming. Suppose the instrument station is A, the point of height known is B, which we have to calculate. The vertical height from line of culmination taken as H. Take this point as C, where we are bisecting the object, the base, and the horizontal distance as D. A dash, from where we are measuring the vertical angle, and the vertical angle as alpha 1. So vertical angle between 2 points, your line of culmination and the object is alpha 1. Now first reading we taken on benchmark, we write it as BS. The height we can say H1. Okay, by knowing all this, now we have to calculate what? We have to calculate H by knowing alpha and D. So how to calculate? We'll see in next slide. A is instrument station, B is point of the observed, H is elevation of B from the instrument axis, we already discussed. D is your horizontal distance between A and the base of object, between A and the base of object. D is horizontal distance which is accessible. Now we have to find out what? RL of B. The main object is to find out RL of point B. So RL of B will be equal to what? RL of benchmark, already known. As we know, benchmark is what? The point of known RL, plus BS, the first reading taken on benchmark, plus d tan alpha. D tan alpha is nothing but what? Your h. Plus, if the distance is large, then we have to add CC and CR. CC means what? Correction for curvature, and CR correction for refraction. If the distance is large, if the d is large, then only. Otherwise, we have to not use, or we have to ignore the correction for curvature and correction for refraction. So, H1 is what? Height of instrument, as we have seen in figure. BS will be reading of staff kept on benchmark, and alpha is angle of elevation between A, B and C. So angle BAC. Now the H is d tan theta. How we calculate H? As we know, here the alpha 1 and this height we have to calculate, which is H, and D we know. So which formula will be using? Opposite upon adjacent, which is nothing but tan theta. So tan theta is what? Opposite upon adjacent. So over here theta is alpha. So tan alpha is equal to h by d. So d is equal to what? Sorry, h is equal to what? We have to find out h. So h is equal to what? H is equal to d tan alpha. And if you have to find out d sometimes, then d is equal to what? D will be simply h by tan alpha. But over here we are required to find out h only. So h is d tan alpha. Now moving on to the next point. Next case was base of the object is inaccessible. The instrument station in the vertical plane as the elevated object. Now what they are saying, the base of the object is accessible. The base of the object is inaccessible. We can't go over there, and it is on elevated portion. But the instrument station in the vertical plane as the elevated object. Both the instrument station as well as the elevated object, both are in the same vertical plane, in the same line. It means it is in same line. So here, as we can see, A and B are two instrument stations, and the line of culmination, this line of culmination is passing through the same height for both the points. Now, as you can see, we have two stations, A and station B. Then we have the benchmark, whose RL is already known. We take first reading on benchmark, which is BS. Then the horizontal distance between AB is taken as small b, whereas the horizontal distance between A to the object base is taken as B. The height of the object where it cuts your line of culmination, we take a point known as B dash, and the total height from your object to the line of culmination or instrument axis is known as H. Now over here we have two thetas, which are represented by alpha 1 and alpha 2. We use two triangles. So as you can see, the instrument axis at the same level. In case 2, the first is instrument axis are at first level. So by seeing the figure, we can see that triangle E, A dash, P dash, H is directly find out. H is equal to same D by tan alpha. Which formula we are using? We are using a simple formula of trigonometry, which is alpha 1, here are H and here D. So tan theta is equal to H upon D. So tan alpha 1 will be equal to what? H upon D. So we have to find out H, then it is D tan alpha 1. Same for second triangle. If we are using second triangle, which is P, B dash P, H will be equal to B plus D, because the distance is more. In that case, for station B, the distance is B plus D. So we are using H is equal to H is common, height is same, but angle is different, alpha 2. So tan alpha 2 is equal to what? H upon B plus D. Find out H, B plus D tan alpha 2. Now, as H is common, so H is equal to H. Is substituting the values of 2H. d tan alpha 1 is equal to b plus d tan alpha 2. We get multiplying tan alpha 2 with b, so b tan alpha 2 plus d tan alpha 2. Now we have to simplify the equation. So we are taking the values of d with same side. So as we have transferred d to that side, it will be minus d tan alpha 2, and taking d common, the value will be tan alpha 1 minus tan alpha 2 is equal to b tan alpha 2 is same. So we have to calculate the value of what? D. We require horizontal distance because the point of base of your object is inaccessible. We can't directly calculate the distance, whereas in case 1 we can directly calculate the distance. So now d is equal to what? D is equal to d tan alpha 2 over it is, and this tan alpha 1 by tan alpha 2 will go to subtraction. So we get the value of d. After knowing d, the next step we have to calculate what? H. The formula of H will be what? The formula of H will be putting this value in your previous equation. The H is equal to d tan alpha 1. So H will be b tan alpha 2 into tan alpha 2 upon tan alpha 1 minus tan alpha 2. Thus we have to put this value in your equation 1. So it will be tan alpha 2 and this will be tan alpha 1, as it is the formula is d into tan alpha 1. So just put this value in equation 1 over here. So we get d as well as h. Then by knowing d and h, next step is we have to calculate what? We have to calculate your RL. So how we'll calculate RL? The formula of RL is RL of P is equal to RL of benchmark, which is already known, plus BS, the first reading taken on your benchmark, plus H, and H we have already calculated. So by knowing the formula of D and H, we can calculate the RL of point P, which is actually required. Okay, now in case 2, there are 2 more sub cases. This is the simple case where the line of collision of 2 points is on same level. Now the next case, instrument axis at the same level, same case, but now here the height of instrument axis near to the object is lower. In that first case, what happened? The instrument axis of both the object was at same level. Now here the object near to your, the instrument axis near to your object is lower. So we'll see, we'll draw first figure and then explain you what is the given criteria. So over here what happened, suppose we start with your first object, that is your benchmark over here. So we have a leveling staff at benchmark. Now as mentioned earlier, what happened, the objects having near to your object, the station near to your object having line of sight lower than the station far from your object. So we know as a B, it is A. So line of sight of both the object is not at same level, it is at different level. As we can see over here, it is at different level. So we can write it as, and the difference between these two is write as HF, difference of height. Then the horizontal distance between B and A is your small b, and the horizontal distance between A and the object base is taken as D. Whereas we can say these points are P dash. Then by knowing the vertical angles of 2 points taken as alpha 1 and alpha 2, the height from B will be h2 and the height from A will be h1. So as we can see in the figure, what we have done, The case is same, but the problem is the instrument axis near your object is lower than the other instrument axis. Now what is the problem over here? Now we have 2h. We have to find out two heights, h1 and h2. So we'll see what is the relation of it. Okay, you have seen the figure correctly. Now we'll see what is the relation of it. We have two alphas, we have two horizontal distance, and as well as we have two h1 and h2. So we have to apply the formula for h1 and h2, and then we'll see what is the next procedure. Now as you can see, the instrument axis at the same level. Okay, the height of instrument axis near to the object is lower. Now the first triangle as we have drawn, the object P, A dash, P dash, height is h1. Simple formula we have to use, opposite upon adjacent. So tan alpha 1 is equal to what? h1 upon d. So we have to calculate d only. So d is equal to what? D is equal to what? h1 upon tan alpha 1. And if we try to find out h1, then h1 will be what? D into tan alpha 1. Now next step, triangle, second triangle, P, P dash, B dash. In that triangle, we'll get h2, second height. So h2 is equal to what? The horizontal distance increase now. From object base to A is D, and from A to B is small b. So total length will be b plus d into tan alpha 2. By knowing h1 and h2, now hd or hf is the difference between two heights. We have calculated difference between two heights. So it will be what? hd is equal to, the larger height was h1. So h1 minus h2 will give us hd. So over here we have to substitute the values. After substituting the values of h1 and h2 from equation 1 and equation 2, we get hd is equal to d tan alpha 1 minus d plus d tan alpha 2. Simplifying the above equation, we'll get d as a common, then tan alpha 1 minus tan alpha 2 minus b tan alpha 2. So hd, we require d. So substituting other values at the same side. So over here minus b will be plus. So plus b tan alpha 2, and we require d only. So substituting the value of d. So d is equal to what? hd plus b tan alpha 2 upon tan alpha 1 minus tan alpha 2. As we don't know the horizontal distance, we have to calculate it. So we can calculate it by using the formula of d. The second formula of d can be d plus hd cot alpha 2 into tan alpha 2 upon tan alpha 1 minus tan alpha 2. We can use either of these formulas. Either formula you can use and calculate d. Now we have to calculate h. How will you calculate h? Put this value, the value of d, in which equation? In equation number 1. So putting the value of d in equation number 1, we will get the height h1. How will you get the height h1? The formula of h was d tan alpha 1. So putting this value in equation 1, we will get d tan alpha 1, d ka value we can use either of this, either this value or either this value, and we can calculate the height h1, the actual height of your instrument. So finding out h2, we can simply put this value in equation number 2. So we can get the value of h2 also, or we can calculate the value of h2 by knowing this equation h1 and hd. So just we have to use trigonometric formula, simple trigonometric formulas we have to use. Just we have to draw a figure and we have to apply the triangular corrections and triangular methods to it. So by using this we can calculate. Now there is one more case. In this case, what happened? The instrument axis at the same level, but the height of instrument near to the object is higher. Now it is second case, continuation of second case only, but here the problem is what? The problem is the height of your instrument axis is your object P. Now over here we have two instruments on a sloping ground, A and B. As we can see, the height of axis of instrument A, which is near to object, is greater than the height of instrument B, which is far from your object. Now same, the difference between two height of collimination will be HD. Then from B, the distance from B to A is small b, and distance from A to your object is D. We put those points as P dash. Now from angle alpha 1, if we bisect your object P from A, and we got alpha 2 by bisecting the angle from station B to your object, then the heights. Now H1 will be from object to the line of collimination of A, and H2 from P to the line of collimination of B. Now you can see here again we form two triangles in this case, but the triangle P A dash P dash, that is angle alpha 1, will get H1 by using P B dash P dash. Using alpha 2 will get what? Will get H2. Okay, we'll see this case how it is different from your previous case. So now in this case, as I have discussed, triangle P A dash P dash will give H1, which is equal to what? D tan alpha 1. Simple formula we have to use. Tan theta is equal to opposite upon adjacent side. Same for next triangle. Next triangle is triangle P B dash P dash. H2 is what? The horizontal distance is increase B plus D. The formula was B plus D tan alpha 2. Now knowing both H1 and H2, we have to find out the HD, difference between your two heights. So HD is equal to what? Now H2 minus H1, as the height of H2 is bigger, greater than your H1. So HD will be substituting the value of H2 and H1 in above equation, BD tan alpha 2 minus D tan alpha 1. Now simplifying the above equation, because we have to get the value of D. So simplify it, multiply inside. So B tan alpha 2 plus D tan alpha 2 and minus D tan alpha 1 as it is. Now taking D as common, so D tan alpha 2 minus tan alpha 1 in bracket. Now we require what? Only D. So this B tan alpha 2 will go on that side and it will get subtracted from HD. The next step, we have to require only D. Then formula of D will be what? Formula of D is HD minus B tan alpha 2 upon tan alpha 1 minus tan alpha 2. If we can reshuffle it, then it will be what? B tan alpha 2 minus HD upon tan alpha 1 minus tan alpha 2. Or else we can either write this formula as what? B plus HD cot alpha 2 tan alpha 2 upon tan alpha 1 minus tan alpha 2. The next step required is what? We require the H. So simply substituting this value in equation number 1. The value of D will substitute in equation number 1 and will get the value of H1. Or by substituting in equation number 2, will get the value of H2. So substitute it. H1 is equal to what? Either use formula of D, either of those two. So substituting this value of D and multiply it by tan 1 will get the equation desired. So as we can see, there are basically two cases. First case is known as one plane method, because that case we require only one instrument. In case 2, it is known as two plane methods, because in which we required two set of instruments. So two instruments can be at same level, then one instrument near to the object it has lower level, or in third case what? The one object near to your instrument, the instrument of nearing object is at higher level. So case 2 is divided into 3 sub cases. So by using these formulas, we can simply find out D and H. And how to find out RL? So RL of P, RL of object is equal to what? RL of your benchmark, right, plus BS, the first reading we have taken on benchmark, plus H1. If I am using a instrument only to calculate BS, then we have to add H1. If we are using second instrument to calculate RL, then we have to use BS from the second instrument. Thank you.